Friends, today I'll introduce very interesting circuit. At first I'll introduce the part of this circuit. This is display. You can see the display of temperature, and these three buttons, this is to set when the relay will be on and when relay will be off. On and off as per your choice you can set. Then these 4 pin we are using, this 2 pin to operate this circuit. I am giving 12 volt power supply, and this entire side, this 2 pin for output. That this is simply a relay and we are taking output. Say for example, in some room there is a temperature of 25 degree, and now you want to cool down. If the temperature is increased above 25, then this device will automatically turn on the cooler so that you can keep the temperature constant 25 degree in that room. In this circuit I'm using, see, this is relay and this is 5 ampere relay, and I'm taking output from these 2 pin. This is for sensor, these 2 pin, this is for the sensor. We'll insert the sensor here, and now I'm going to show you 3 sensor. All are different. First one I'll introduce this is metal sensor. This is also called NTC thermistor, and this is 15K. The value of this sensor is 15K. I'll show you another sensor. This is coated NTC thermistor. Just see this head of this sensor. This is 10K. This is called 10K NTC sensor. This is 15K, this is 10K. And I'll show you another sensor. This is around 8K. This sensor is suitable for this circuit, because if you use this kind of sensor or these, then you will not get the actual temperature. The calculation will be wrong. So we are using this sensor, and this is the connector jack. I'm using this sensor to control this room temperature. At first I will switch on this. That means I'll give the power to operate this circuit. Then I'll introduce another part. I'm using 12 volt homemade power supply. I'm giving, see, this circuit is showing LLL. That means it's showing temperature is low. Actually the sensor is not connected yet, that's why it's showing low. Now just see the changes. I'll just insert this. Now it has been changed. Now again I'll remove this. I'll show you a low. Then once it is connected, then you just listen carefully. You will get some noise of relay. See, this is basically, I have selected here only 10 degree temperature, so that in some room when the temperature is above 10 degree, then I can switch on the cooler automatically. This circuit will control that cooler or any other device. Now the temperature is showing 35.3 degree. For your better view, I'll change the light. This is 35.3 degree. Now I'm using this cup. I'm using few ice cube. See, few ice cubes are there. Now see, the temperature is showing 34.5 degree, around 5 degree, 35 degree. Now I'll put this sensor here. Now see the changes. Recording disturb now. Now temperature is decreasing and it's became 2.7, 2.2, 2.5. If you monitor closely, see inside this board there is a LED, just this here. This light is off. That means this relay is off right now. Now I'm removing this sensor. Now see the changes. This light will be on when the temperature is 10. This light will be on. Just see here. 9.4. It will be on automatically. The set temperature was 12 degree. That's why when the temperature is 12 degree, then this relay will be on. Again I will show you. This light is on. That means the relay is on. Now temperature is increasing as it is removed from this ice. Now I'll put it again. Just follow this. Then again it is off. I'll show you. I repeat. The on timer is 12 degrees centigrade. See, just 12 degree. Once it is 12 degree, then light is on, and when it will be off, that time I've selected 10 degree. Again, put it inside the water. You see, through this relay you can operate any kind of device, and this is the main function of this board. This temperature is increasing. Just see. It is very useful circuit, and through this you can control the temperature of your room, or for any purpose you can control the room temperature. That's all my friend, and if you like this video, please subscribe and press the bell icon so that you can get the latest video. Thank you.